everyone. In today's lesson, we're going to talk about graphing our quadratics using the zeros, okay? There are a few steps to follow. First and foremost, we're going to find our y-intercept, and then this is going to be from our standard form. We then need to find our x-intercepts by solving our quadratic equation, i.e. we need to factor and set it equal to 0. We need to find the axis of symmetry, which is halfway between our x-intercepts. And we need to find our vertex. We're going to use our axis of symmetry to find our minimum or our maximum value. And once we have those pieces of information, we can go ahead and graph. So let's jump to it with our first example here. Y is equal to x minus 3, x minus 1. Well, immediately I can pull some information here because I have my factored form. I can pull out my x-intercepts. My x-intercepts are going to be at positive 3 and positive 1. Okay? If I want to do that more formally, I could set 0 is equal to x minus 3, x minus 1. That would be x minus 3 is equal to 0, x minus 1 is equal to 0. Rearrange and solve for x. X is equal to 3, x is equal to 1. So we have our two x-intercepts right here. I'm going to go ahead and plot those on our grid. So x is equal to 3 and x is equal to 1. Those are our two x-intercepts. Let's find our y-intercept now. Remember, the y-intercept is easily pulled from standard form, so let's go ahead and expand this. Our standard form is x squared minus 4x plus 3. So our y-intercept is going to be located at 3. I'm going to go ahead and plot that as well on my grid. So we can already tell we kind of have a bit of a parabolic shape here. Okay, you know it's going to be parallel or even on the other side. It looks like it's going to be going up. It wouldn't make sense for it to be going down because then it wouldn't pass through one of our x-intercepts, so it has to be opening up. Now let's find our axis of symmetry. Okay, the axis of symmetry is located halfway between our two x-intercepts, so we're going to do 3 plus 1 over 2, which is 4 over 2 or just 2. And so to be helpful, what you can do is draw a dashed vertical line at x is equal to 2. So that's what I'm going to do here. I'm going to draw this line. And so we know that that's going to be the halfway point of my parabola. I now need to find my vertex. So I'm going to say, okay, in order to find the vertex, I need to set x equal to 2 in one of my equations, and I'm going to use the factored form, the original one that was given. So I'm going to do 2 minus 3 times 2 minus 1. 2 minus 3 is a negative 1. 2 minus 1 is 1. Negative 1 times positive 1 is negative 1. So my vertex is located at 2, comma, negative 1. I can go ahead and place a dot at 2, negative 1, which is right there. So we have our 4 points here that we can use to graph: y-intercept, x-intercepts, and vertex. And we can go through and draw our parabola. It doesn't have to be beautiful, but it does have to pass through those 4 points. Let's do another example. Y is equal to 4x squared minus 4x minus 35. Right off the hop, we can grab our y-intercept being c. Our y-intercept is a negative 35. Now we need to factor in order to find our x-intercept. So I'm looking for two numbers that add to negative 4 and that multiply to negative 140. Those two numbers are going to be negative 14 and positive 10. I'm going to factor this by grouping. I'm just going to rewrite my equation over here. Break it down, 4x squared minus 14x plus 10x minus 35. I can factor out a 2x from my first two terms, leaving me with 2x minus 7. And I can pull out a 5 from my second pair, so I can pull out 5, leaving me again with 2x minus 7. In full factored form, I have 2x plus 5, 2x minus 7. Now we need to find our x-intercepts. So my x-intercepts are going to be when this is equal to 0. And that means I have to either set 2x plus 5 equal to 0 and 2x minus 7 equal to 0. 2x plus 5 is 0 is going to give me x is equal to negative 5 over 2. And 2x minus 7 over 0 is going to give me positive 7 over 2. So I have two x-intercepts and I have my y-intercept. Let's go ahead and start plotting these on our grid. Now it's hard to imagine sometimes what fractions are going to look like on a grid, and so you can convert these into decimals if it's a little bit easier. Negative 5 over 2 is negative 2.5, so approximately right here. And 7 over 2 is 3.5, so approximately right here. A little more to the left. And negative 35 is all the way down here. So we can already start to see the shape of our parabola. Once again, we can see it is opening up. Now we need to find our axis of symmetry. Our axis of symmetry is exactly halfway between these 2 points. So I need to add negative 5 over 2 plus 7 over 2, all divided by 2. Negative 5 over 2 plus 7 over 2 is 2 over 2 divided by 2. 2 over 2 is just 1, so my axis of symmetry is located at 1 over 2. And once again, you can go ahead and draw a guiding line along your axis of symmetry. Mine is right about here, along the x value. And let's finish off by finding our vertex. So our vertex is located when y is equal to, or when x is equal to 1 over 2. So I'm going to do 2 times 1 over 2 plus 5, and then 2 times 1 over 2 minus 7. 2 times 1 over 2 is 1, plus 5 is 6. 2 times 1 over 2 is 1, minus 7 is negative 6. 6 times negative 6 is negative 36. So my vertex is a little bit lower there, it's right about there. And finally, we can go ahead and sketch, connect these 4 points, x-axis or x-intercept, y-intercept, vertex, and back up. This one is a little bit less pretty, but you get the point. It is still shaped like a parabola. Finally, let's look at our third example here. Y is equal to 2x squared plus 8x plus 8. Okay? Before we go ahead and jump to any kind of conclusions, I would say let's start by factoring just to get it out of our system. Okay? I'm going to go ahead and factor. I'm going to common factor out a 2 from all terms first because I can, leaving me with x squared plus 4x plus 4. Okay? I can now factor x squared plus 4x plus 4. I'm looking for two numbers that add to 4 and multiply to 4. It's 2, both of them. So I'm going to have an x plus 2 and an x plus 2, which is just x plus 2 squared. So my factored form is going to be 2 times x plus 2 squared. Okay, let's start to pull some information. First and foremost, my y-intercept is at positive 8. It's at positive 8. So I can go ahead and draw a dot on my grid down here, positive 8. I need to find my x-intercept, so I'm going to do that by setting my equation equal to 0. This means that x plus 2 must be equal to 0, and therefore x is at negative 2. And there's only one x-intercept here, so I only have one dot to draw, located at negative 2. Okay? When this is the case, when there's no two x-intercepts, you don't have to find the halfway point. The axis of symmetry is the same. This is your axis of symmetry. They're the exact same thing. So I can draw a guiding vertical line that also happens to be through my x-intercept, that is my axis of symmetry. And we know that the vertex is located along the axis of symmetry. This is going to be our vertex. It's when it just touches the x-intercept. Okay? So that's nice and easy. Here I only really have 2 points to work with, a y-intercept and an x-intercept. I know that it has to be parallel, it has to be a mirror image of one another, the sides do, and therefore I know that it needs to open up. If it opened down, they would not be mirror images of each other. This is the exact cut in half part. I'm going to go ahead and I can draw my parabola just like this. Okay? And that's all there is to it, folks. So just remember, you need to grab your y-intercept, x-intercepts, then you can find your axis symmetry, find your vertex, and go from there.